So in today's class, we will be doing Poisson distribution. Poisson distribution. In yesterday's class, we had completed binomial distribution, and in today's class, we are doing Poisson distribution. So welcome everyone on the board. Smith is there, Kanishka, Ash Babu, Vishnu Dev, then Unmatla, Priyanka, Rajshri. Okay, welcome everyone. Good afternoon. Good to see you all again. So, in today's class, we are talking about the topic Poisson distribution. Now, Poisson is again the part of discrete probability distribution. Under the heading discrete, we had discussed two distribution. First one is binomial and second one is Poisson. So we are doing now Poisson distribution in a bit detail. So what is basically the Poisson distribution? So Poisson is a theoretical discrete probability distribution which can describe many processes, and this was given by Simon Dennis Poisson. Simon Dennis Poisson, and it was first introduced in the year 1837, almost 200 years back. All right. So what are the basic conditions for the Poisson distribution? Great. Many of you have arrived. That's good to see you here again. Okay. So now we are discussing about the conditions of Poisson distribution. Let us write this. Poisson distribution. So what are the main conditions? The first condition says, first condition is somewhat similar to what we have discussed in binomial distribution, that is n. We are talking about n. Here also we are talking about n, but here we can say that n tends to infinity. Here n tends to infinity. In binomial distribution, n was a finite number, but here we are saying that n is very large. Number n is very large such that n tends to infinity. This arrow sign means tends. Arrow means tends. That means n is approaching towards infinity. N is not exactly infinity, but n is near to infinity. Similarly, in second condition, we are saying p tends to 0. That means probability is very, very low. Probability of success here is very, very low. So that is why we have written p tends to 0. That means probability is not 0, but it is near 0. Probability is near 0. All right. And when we multiply both of them, n and p, when we multiply both of them n and p, then what will happen? One value is near to infinite, second is near 0. Both are on extremes, but when we multiply them, both will come into middle. That means there will be an average value, moderate value. So n into p, that is mean, is a moderate value. It is an average value. All right. So n tends to infinity, p tends to 0, and np is a moderate value. So np will be always positive. Np is always positive because number is always positive. Number of trials, number of experiment is positive. Probability is also positive. So its product will also be positive. Then np is a moderate value, it is a finite value, and it can be into decimal. Yes, np can be a decimal value. All right. Now, other conditions are similar to binomial distribution. So what are the other conditions? Like there will be independent events. Events will be independent. And what will be the events? Success and failure. And success and failure will be again mutually exclusive. That means one at a time. Either there will be success or there will be failure. Both cannot occur together, right? Both cannot occur together. So other conditions are similar to binomial, but what are the main condition? N tends to infinity, P tends to 0, and NP tends to a moderate value. NP is a moderate value. All right. Great. So अभी तक हमने सिर्फ 4 basic points को discuss किया है. Now let us discuss the formulas which are based on Poisson distribution. So this Poisson distribution was given by Simon Dennis Poisson. It was given by Simon Dennis Poisson. Now, what is the first formula? The first formula is for calculation of mean. How we calculate mean in case of Poisson distribution. So mean can be denoted as mu or even lambda. Mean can be denoted as mu as well as lambda. And what will be the formula? The formula will be n multiplied by p. The formula is n multiplied by p. Second formula. The second formula says variance. Now, we can recall that we have written same formula for mean, whether it is binomial or it is Poisson, mean is same. But for variance, in binomial distribution, the formula was NPQ. But here, the formula is NP. Here, variance can be calculated as simply n multiplied by p. That's it. We are not multiplying q here. Do you know the logic why we don't multiply with q? Because we say that p tends to 0. And we also know that p plus q is equal to 1. Sum of success and failure is equal to 1. So if p tends to 0, this implies q tends to 1. And if there is anything which is 1, and if we multiply with 1, the result is same. Like 5 multiplied by 1 is 5, 10 multiplied by 1 is 10. Similarly, NP multiplied by 1 is NP. So that is why the universal formula for variance in case of Poisson distribution is n into p. All right. So variance is n multiplied by p. Third one says standard deviation. Third formula is for standard deviation. It is simply square root of n multiplied by p. N multiplied by p. So these are the three formulas. Fourth formula is for probability. But before that, we can conclude here that mean and variance. Mean and variance both are equal. Both are equal in case of Poisson distribution. Whenever there is, we are talking about Poisson distribution, mean and variance are equal. But this was not the case in case of binomial distribution. Both were different. But here, both are equal. All right? Because the formula for both of them is n multiplied by p. All right? Now the fourth formula is for probability. Fourth formula is for calculation of probability. The formula is very simple. E to the power of minus m multiplied by m to the power of x divided by factorial x. Divided by factorial x. E to the power of minus m, m to the power of x divided by factorial x. Now, what is the meaning of E here? E is known as exponential value. E is known as exponential value. Now, there are different kind of values like logarithmic value, exponential values. So here E is known as the exponential value and its value is fixed. e to the power 1 is equal to 2.7183. Just similar to what we learned the value of pi. Pi is basically 22 upon 7, or we say 3.14. Similarly, there is value of e, and which is 2.7183. All right. Great. So these were the basic conditions and formulas for calculation of Poisson distribution. Now we will take some questions based on all these formulas. All right. And before that, we will take one more thing, that is application. What is the application of Poisson distribution? So since P tends to 0, we have seen that probability is very low, it tends to 0. So Poisson distribution is applied when the total number of events is pretty large, but the probability of occurrence is very small. That means n tends to infinity, n is very large number, and p is very, very small. So in such kind of cases, we use Poisson distribution. So we can apply Poisson distribution rather profitability for the following cases. So where it is practically used, the first scene is the distribution of number of printing mistakes per page of a large book. See, there is a large book, 500 pages, 1000 pages, 200 pages. Now, how many misprints are there? How many errors are there per page? Or we can see that a book is having thousands of words, lakhs of words. Out of those thousands and lakhs of words, only few words may have some of the spelling mistakes or some of the errors. That means the chances of error is very, very low. Chances of error is very, very low. For example, a book is having 1 lakh words, and out of those 1 lakh, 10 words is having some of the spelling mistakes. That means what is the probability of error? It is 1 upon 10,000. The probability of getting error is 1 divided by 10,000. So it is very, very low, and n is very, very large. Similarly, the distribution of number of road accidents on a busy road per minute. So per minute, how many accidents are there on a road? So whenever we are talking about such kind of situation where probability is very low, then we use Poisson distribution. Similarly, the distribution of radioactive elements per minute in the fusion process, like how frequently we are using radioactive elements per minute. Similarly, number of demand per minute for the health center and so on. Like if we are having a car showroom and we are taking the example like how many customers are arriving in our showroom per minute. So of course, per minute, the chances of coming new customer is very, very low. It is very, very low. So in all such cases, we are using Poisson distribution. Okay. So now we have read the formula for probability e to the power of minus m, m to the power of x divided by factorial x. So in this formula, what we are basically talking about e, one thing was e is the exponential value, m is known as the mean, m is known as mean. And how we can calculate mean? By simply multiplying n with p, n with p. And what is x? X is always the required value. X is always the required value. Whatever we have to calculate, we have to find out, that is x. All right. So let us come to the question. Also, before these examples, let us do some basic calculations so that it will be easy for you to understand the formula and apply it. So we are taking one simple example. If mean is 2 and the value of x is 1, value of x is 1, and we have to find out the probability when x is equal to 1 using Poisson distribution. So we are simply understanding the calculation, how to calculate probability in case of Poisson distribution. Mean is given as 2, x is given as 1. Sorry, mean is 2 and x is 1. So applying the formula, e to the power of minus m, m to the power of x divided by factorial x. So e to the power of minus 2. Now m to the power of 1 divided by factorial 1. So in this way, we have substituted the given values. Now, what is m? M is 2. So we are writing here 2 to the power of 1. Now, how to solve this? 2 to the power of 1 is 2. Factorial 1 is 1. But what is e to the power of minus 2? What is e to the power of minus 2? So we know that e is equal to 2.7183. And e to the power minus 2 can be written as 1 upon e square, right? 1 upon e square. Now substituting its value, so 1 divided by 2.7183 square. 2.7183 square. So you can solve this. 1 divided by 2.7183 and again divided by 2.7183. So how much we are getting? 0.1353. So this is the value for e to the power of minus 2. So we are multiplying here. So what is the final result? 0.2706. So this is the required probability. So in this way, we can calculate. All right. Yes, Soumya has given the correct answer. Great. Subi has also given correct. So in this manner, we can solve this calculation. Now let us take one more example. If say n is 200 and probability is 2%, x is equal to 0. X is equal to 0. And we have to calculate probability when x is equal to 0 with the help of Poisson distribution. So for Poisson distribution, we always require mean. So we will calculate mean as n multiplied by p. So 200 multiplied by 2%. So what is 2% of 200? It is simply 4. So mean is equal to 4. Mean is equal to 4. Now applying the values, e to the power of minus 4, then 4 to the power 0 upon factorial 0. So what we are left with simply e to the power of minus 4. And we can simplify this on calculator. So 2.7183 power 4 and then 1 divide MRC. So how much we are getting? 0.0183. So this is the result. All right. Okay, Anshu is saying explanation in Hindi, please. Okay. So यहाँ पर हमने जो एग्जाम्पल लिया है, इस एग्जाम्पल में n was 200, probability is 2% and x जो required value है that is 0. तो पहले हमें क्या करना है? मीन फाइंड आउट करना है एंड मीन को फाइंड आउट करने के लिए हम क्या करेंगे? n को मल्टीप्लाई करेंगे p के साथ में, n को p के साथ में मल्टीप्लाई करेंगे, so we will get m, that is mean. So 200 multiplied with 2%, so mean is 4. Mean becomes 4. Now we have to calculate the probability. तो probability के फॉर्मूले में हमने mean पुट किया 4, x की वैल्यू पुट कर दी 0 एंड ये दोनों पुट करते ही फाइनल रिजल्ट जो हमारे पास आया है दैट पॉइंट 0.2706 0.0183. Okay. Yes, Akash, value of E is fixed 2.7183, and we can change the value according to the power. Priyadarshini is asking about weightage of the chapter. See, Priya, we have discussed yesterday the weightage of chapter is average 5 marks. Okay. Okay. How to solve this calculation on calculator? See, it is very easy to calculate. Let me explain. We are calculating e to the power of minus 4. All right. Now, first of all, this can be written as 1 upon e to the power of 4. And we know that E is equal to 2.7183. So first of all, we are calculating e to the power 4. How to calculate this on calculator? Type 2.7183 into equal to and equal to. Since power is 4, we have to press equal to 3 times. Equal to 3 times. After pressing equal to 3 times, press M plus button. Press this memory button. All right. Now in the next step, what you have to do, we have to divide 1 divided by MRC and press equal to. Press equal to. After pressing equal to, you will get the desired result. Okay. You will get the desired result. So in this way, you can solve this on calculator. 2.7183 into equal to 3 times, then M plus. And at last 1 divided by MRC equal to. You will get your result. Okay. Perfect. Mitra is asking about 0 factorial. 0 factorial is basically 1. Okay. We had discussed this in chapter permutation combination. Now let us take one more basic, and after that we will move towards illustrations. Now let's say mean is equal to 2 and find out the probability when x is more than equal to, or we can say x is less than 2. Find probability when x is less than 2. We have to solve this. Now, whenever we are given such kind of situation, x is less than 2, which means x can be 0 or x can be 1, because x cannot be negative. Required number cannot be negative. It can be 0, it can be 1. So less than 2, there are only two numbers, 0 and 1. Now you can solve these two. So this implies probability of x equal to 0 plus probability of x equal to 1. Right? Now applying this formula, e to the power of minus 2, 2 to the power of 0 divided by factorial 0 plus e to the power of minus 2, 2 to the power of 1 upon factorial 1. Now what is common here? E to the power of minus 2 is common here. So we can keep 1 plus 2. We are left with 1 plus 2. So 3 multiplied by e to the power minus 2. And we have just calculated above e to the power minus 2. It was 0.1353. 0.1353. So what is the final result we are getting? 0.4059. 0.4059. This is the result. So in this way, we can calculate all such kind of calculations. All right. Yes. So now you can find this topic very easy. Otherwise, what is happening? Most of the students are leaving this topic just because they feel it difficult. But seriously, this topic is not at all difficult if it is understood in this manner, in this basic manner. So it is very easy, whether it is like examples, questions. From if we see from exam point of view, this topic is very much scoring as well as interesting. Okay, great. Now I'm coming towards the next point, which is 17.11. Find the mean and standard deviation of x, where x is a Poisson variate satisfying the condition p x equal to 2 and p x equal to 3. So here, what is our requirement? The question says find mean and standard deviation. We have to calculate both of them. But for solving this, one equation is given. So let us solve this equation. P x equal to 2, and on opposite side we are having x equal to 3. Now don't get worried with such kind of question. These type of questions are very easy. Since it is P means probability. Just apply the formula for probability and you will get your result. So we are applying e to the power of minus m. M is not given, so we are writing m as it is. M to the power of x. X is 2 divided by factorial x, so factorial 2. On opposite side, e to the power of minus m. Again, m to the power of 3, this time x is 3, divided by factorial 3. Factorial 3. Now we can cancel some things. So e to the power of minus m got cancelled. M square got cancelled with the m cube. So what we are left with? So now we are left with m 1 upon 2 is equal to m upon 6. So m is simply 6 by 2, that is 3. M becomes 3. Now it becomes super easy. M is 3. M means mean. Mean is 3. Mean is also equal to variance. So variance is also 3. And what will be standard deviation? Standard deviation is root of variance. That is root of 3. Okay. So this is super easy question. And such kind of questions come in exam. Okay. All right. Now the next one, 17.12 we are solving. The probability that a random variable x following Poisson distribution would assume a positive value is 1 minus e to the power of minus 2.7. What is the value of mode? What is the mode of the distribution? So this is the given question now. Now, how to solve such kind of questions? So again, this is very much easy. What we have to do, we have to just apply the formula here. Now, what is the formula? We can see that e to the power of minus m, m to the power of x upon factorial x. Now, what is x here, or what is mean here? Is any information is available or not? So we have to see here what kind of information is available with us. So we are simply given that Poisson distribution would assume a positive value, that is the probability is given in terms of e, that is 1 minus e to the power of minus 2.7. This is given. Okay. This is the given thing. I think there is some error here. Let me do this. Yes. So this is the given value here. Now we can compare this. So 1 minus e to the power of minus m. I think there is some error here. Once again, guys, I will close the application and start it once again. So I'm pausing the screen for a few seconds. Yes, guys. Sorry for the interruption. Yes, so we were discussing about the probability that it is the given result is 1 minus e to the power of minus 2.7. This is the given thing. And now what is the formula? The formula says e to the power of minus m, m to the power of x, and then divided by factorial x, divided by factorial x. So simply what we have to do here, we have to compare the two things. We have to simply compare the two things. So for comparison, what basically we are doing here, we are assuming x any positive value. Positive value means greater than 0. So if x is greater than 0, x is greater than 0, that means x can be 1, 2, 3, 4, and so on, up to what? Up to infinity, because n tends to infinity. That means x will go up to n, that means near to infinity. So whenever there is probability of x more than 0, what we have to do? We have to solve 1 minus probability of x equal to 0. What we have to do? 1 minus probability of x equal to 0. Now, what is x equal to 0? Okay, right. So there was some fluctuation into internet, so it happens sometimes. Okay, no worries. Let us continue now. So we were talking about this Poisson distribution, and in this question we are getting 1 minus e to the power of minus m, and the given value is, what is the given value? It is 1 minus e to the power of minus 2.7. Now on comparing both the sides, what we get, 1 and 1 got cancelled, minus and minus got cancelled, base is same, and now whenever base is same, then the power are equal, so we can equate the power of both the sides. So what we are getting mean as 2.7. We are getting mean as 2.7. All right, so this was the case in 17.12. Let me take one more time because we got disturbed in between. So this question was saying that the probability that a random variable x following Poisson distribution would assume positive value is 1 minus e to the power of minus 2.7. Then what is the mode? So this was the case. So here, what we have to do, there is positive value. Positive value means x will be greater than 0. Whenever it is greater than 0, it is 1, 2, 3, and so on up to infinite. So for solving this, we have to do 1 minus probability of x equal to 0. So 1 minus e to the power of minus m to the power 0 upon factorial 0. This is equal to the given value in question, right? On comparing both the sides, what we are getting, we are simply getting mean as 2.7. We are getting mean as 2.7. Also, variance is equal to 2.7. Both are same. Both are same. Mean as well as variance, both are 2.7. All right. Now, how to calculate mode here? So for calculation of mode, there is a formula similar to what we discussed in binomial. So we write here calculation of mode. Calculation of mode. Point number first, if n into p is a whole number, say k, then mode is equal to k, comma k minus 1. If n multiplied by p is a whole number like k, then mode will be k and k minus 1. And if n into p is not a whole number, if it is not a whole number like k plus f, then mode is equal to simply k. We will remove the fraction, just similar to what we discussed in binomial. In binomial, it was n plus 1 into p, but here it is simply n into p. That means mean. This can also be written as mean, right? So we can write here if m, that is mean, and also here we can write m. So one and the same thing. So if mean is a whole number, then mode will be k and k minus 1. And if mean is not a whole number, then mode will be k. So in the given question, we have calculated mean as 2.7. So it is not a whole number. We will remove the decimal part and the answer will be 2. So mode is equal to 2. Okay. Mode is equal to 2. Now, Now let's come to our next question, 17.13. The standard deviation of Poisson variate is 1.732. What is the probability that the variate lies between -2.3 to 3.68? So what is given here? Standard deviation is given. Standard deviation is given. So from standard deviation, we can calculate variance. From a standard deviation, we can calculate variance. So squaring standard deviation, that is 1.732 square. And on squaring, we are getting 3. So this 3 is basically variance as well as mean. So from standard deviation, we have computed mean, which is 3. Now we have to find out the required value, that is x. And x should lie from -2.3 to 3.68. See, we know that x can always be a whole number and always a positive value. X cannot be negative. X cannot be negative. So we have to find out positive whole numbers between -2.3 to 3.68. We have to find out positive whole numbers between -2.3 and 3.68. So what are those positive numbers? And in that, 0 is also included. So 0, 1, 2, and then 3. 0, 1, 2, and then 3. So these are included here. All right. Now we can solve this question by using our formula for probability. So p to the power of x is equal to e to the power of minus m to the power of x divided by factorial x. So let's apply this formula. Probability is equal to e to the power of -3 to the power 0 upon factorial 0 plus e to the power of -3 to the power of 1 upon factorial 1 plus e to the power of -3 to the power of 2 upon factorial 2 and one more. So now we have applied the formula and we can take common. E to the power -3 is common here. So what we are getting, 1 plus 3 plus 3 square is 9. 9 divided by 2 is 4.5. And then 3 cube is 27 and 27 divided by 3. 27 divided by, 3 factorial, which is 6. So how much we are getting? 3.5. So what will be the result? It is how much? 1 plus 3, 4. 4 plus 7. 4 plus 8 is 12. All right. So overall, how much we are getting? You can check. 3.5 plus 4.5 plus 3 plus 1. Overall, we are getting 12 e to the power of -3. We are getting 12 e to the power of -3. Now we can solve e to the power of -3. So 2.7183 cube m plus 1 divide MRC, and then we are getting 12 multiplied by 0.0497. So finally, what is the result? The result will be 0.597. 0.597. Okay. So this is the required result. Or if it correct the values, I think I've taken 3.5 here. We can change it here, 13. So by applying 13, what we are getting 0.65. All right. So this is the correct answer, 0.65. And in front of it, there is a sign of similar. That means 0.64 something, and which is rounded off to 0.65. All right. So in this way, we can solve such kind of questions. Now, 17.14. This question has been repeated many times into exam. Let's solve this question now. X is a Poisson variate satisfying the following relation. So we are given a relation and we have to find out the standard deviation of X. We have to find out the standard deviation of X. Let's do this. Probability X equal to 2 equal to 9 times of probability X equal to 4 plus 90 times of probability X equal to 6. Okay. So this is the question and we have to find out the standard deviation. The standard deviation. So let's apply the formula. Let's apply the formula. E to the power of minus m, m to the power of 2 upon factorial 2 equal to 9 multiplied by e to the power of minus m, m to the power of 4 upon factorial 4 plus 90 multiplied by e to the power of minus m, m to the power of 6 divided by factorial 6. Now we can take common. Left hand side is same. On right hand side, we can take 9 e to the power of minus m and m to the power of 4 as common. So all these are common. So what is left with us? We are left with, also we can take 4 factorial as common. 4 factorial also common. So 1 plus 10 m square divided by 5 into 6. 5 into 6. So let's cancel some of the values. M square will also get cancelled. So factorial 4 can be written as 24 and we can cancel 2 with the 24 also. So how much we are getting now? Let's check how much we are getting. Come on, you can solve now. So 1 is equal to, now here also 9 and 12 will get cancelled. 3 and by 4. 3 with 4. So what is left outside? 3 by 4 m square. Inside there is 30 plus 10 m square. Okay. Now you can take cross multiplication and prepare the equation and solve now. All right. It's now easy for you to solve. So 4 is equal to 3 m square and multiplied with 30 plus 10 m square. So you can solve this kind of equation. And also, if options are available, you can simply substitute the value and get the result. All right. You can also substitute the value and get the result. All right. So let's move towards the next question. You can simplify this now. Yes. Now, interpretation of this 15th example. This is a good question. Between 9 and 10 a.m., the average coming into the switchboard of a company is 4. Find the probability that during one particular minute, there will be no phone calls. So what is given in the question? There is a time period that is from 9 to 10 a.m. Number of phone calls, which is average. Average means mean. So this is average per minute is 4. So we are saying that mean is equal to 4. Now, what is the probability that during one particular minute there is no phone calls? No phone calls means x is equal to 0. So if m is 4, x is 0, we can solve this first part. Probability when x is 0. So e to the power of minus 4, 4 to the power of 0 upon factorial 0. So how much is left? E to the power minus 4. And we can solve this on calculator. So it is 0.0183. So this is the final result. And after that only you will get your result. Rashri has got the value as 1. Yes, Rashri, you are correct. 1 is perfect. So 17.15 first part is done. Now, in case of second part, what is the requirement? At most 3 phone calls. At most means maximum 3 phone calls, not more than 3. Not more than 3. So what we will write in place of x? Maximum 3 phone calls. So 0, 1, 2, and then 3. Now you can solve this. Take the value of x as 0, 1, 2, and 3 and give the answer. Come on. You can do this. Priyanka is asking about 13th example. Yes, Priyanka, in 13th example, the total will be 13, not 12, because the last part is 4.5. 27 divided by 6 is 4.5. So total will be 13. All right. So you have to solve now second part of this question where x is 0, 1, 2, and 3. And here also you can take common e to the power of minus 4. And after taking common, your calculation becomes very easy. All right. Yes, Kanishka has got the answer 0.43. 0.43 is correct. All right. Yes, now everyone is getting the answer. Shubhi has done. Chavi has done. Shana has also done. Vinayak, your answer is not correct. You can check it once again. Okay. So let us move towards the next question. And the next one says, if 2% of electric bulbs manufactured by a company are known to be defective. Now, what is given? 2% of the electric bulbs are defective. Now, what is the probability that a sample of 150 electric bulbs taken from the production process would contain exactly one defective bulb? It would contain exactly one defective bulb. So this is the kind of question. How to solve this? So always try to write the given values and you will get your result. So what is given? 2% of electric bulbs are defective. So this is the probability of defectives. So P is 2%. We have taken a sample of 150 electric bulbs. So N is equal to 150. So from these two, we can calculate mean. 150 multiplied by 2%. That is 3. That is 3. So mean is equal to 3. Now, what is our requirement? Exactly one defective bulb. So X will be equal to 1. X will be taken as 1. So let's solve this. E to the power of minus 3, 3 to the power of 1, and then divided by factorial 1. So how much we are getting? 3 multiplied by e to the power of minus 3. And we already know how to calculate e to the power of minus 3. So what is the final answer which we are getting? It is 0.1493. 149, or by rounding off, we can write as 0.15. 0.15. This is the answer. Okay. Yes, most of you have given the correct answer. Kanishka has given, Ujjwal, Aditya, Ayushi, Priyanka Gupta, Soumya Shukla, Jyoti Rani, Ruchi, everyone. Prakash Solanki, Nikita Sankla, Adivya Pathak. Great. Good going, everyone. So this was first part. Now in second part, what is the requirement? More than 2 defective bulbs. See what we will write into X. Now you can comment on this X. How to solve this second part and what will be X? More than 2 defective bulbs. More than 2 defective bulbs. Come on. Now you have to tell the correct answer. More than 2 defective bulbs. Come on, guys. You can give now. So more than 2 means 3, 4, 5, and so on up to infinite. But we cannot solve this up to infinite. For solving, what we have to do, probability of x, 0, 1, and then 2. We have to take those values which are not taken here. So we have to minus from 1. 1 minus probability of x, 0, 1, and then 2. Right? Since 3, 4, 5, 6, and so on is required, so we will be subtracting 0, 1 and 2 from 1. So let's solve this. 1 minus probability of x, 0, 1 and then 2. So e to the power of minus 3, 3 to the power 0 upon factorial 0 plus 3 to the power minus 3, 3 to the power 1 upon factorial 1. And then 3 to the power of 2 upon factorial 2. So what is common here? E to the power of minus 3 is common. So we are getting 1 plus 3 plus 4.5. 4.5. So how much we are getting? 0.0497 multiplied with 8.5 and then minus from 1 and then minus from 1. So we are getting 0.5768. If we round it off, 0.58. 0.58. So many of you have given the answer as 2, 3, 4, 5. See, 2 will not be included there because we are given more than 2. So more than 2 means 3, 4, 5. All right. So that is why we have written 3, 4, 5 up to infinite. So 2 will not be written here. It will come downwards. So 1 minus px equal to 0, 1 and 2. So this is a thing to be taken care of. All right. So now the correct answer is 0.58. All of you have done this. That's good. Fantastic. Now let's do the 17th question. The manufacturer of a certain electronic component is certain that 2% of his product is defective. So what is given? Percentage of defective. He sells the components in boxes of 120 and guarantees that not more than 2% in any box will be defective. Not more than 2% will be defective. So find the probability that a box selected at random would fail to meet the guarantee. What is the probability that the box will fail to meet the guarantee? So when will the box fail? The box will fail when defects are more than 2. Box will fail when defects are more than 2. So that means what is the x here? X will be more than 2. So more than 2 means again 3, 4, 5 up to infinite. And for solving this, we have to do 1 minus p x equal to 0, 1, 2. 0, 1, 2. Now what about mean here? So we are given n. N is 120. Probability is 2%. So what will be mean? Mean will be n into p. So 120 multiplied by 2%, that is 2.4. So 2.40 will be mean. Mean is equal to 2.40. Okay. Now we have to solve. So 1 minus e to the power of minus 2.4, this can be taken as common. Then m to the power of x, 2.4 to the power 0 upon factorial 0 plus 2.4 to the power of 1 upon factorial 1 and plus 2.4 to the power of 2 upon factorial 2. All right. So now value is given in the question. E to the power of minus 2.4 is already given in the question, and that is 0.0907 multiplied with 1 plus 2.4 plus square of 2.4 divided by 2. That is 2.88. Now check what is the result. Check the result. So we are getting 0.430. 430. All right. So this is the required answer. Priyanka is asking, can we write into approximate value, or we have to write into 4 digit or 2 digits? We have to round off or not? See, you have to check with the given options. If options are having like after decimal 4 values, you have to also take 4 values. If option has given rounded answer, you have to also take the rounded answer. Okay, so there is no issue in that. So correct answer is 0.43. Everyone has given. Shunaya has given. Prashant, Aditya, Chavi, Dhaneshwari, Soumya, Rajshri, Manisha. Everyone has given the answer. Correct. So this is 17th example. Now we are moving towards next one, which is 18th. 18th illustration is second part is a bit different. And one more thing to note here, whenever mean is coming into decimal, the question will give the value. When mean is having decimal value, then e to the power of minus m will be given in the question. It will be given in the question. Just put it in the previous question also, and now in this example also. Because whenever the value is into decimal, we have to check the exponential table. Otherwise, the question will give itself. So in examination, you don't have to demand for such kind of tables because the question will provide you the values. Okay. But if it is rounded off, we can easily calculate it on the calculator. All right. Now, 18th one, a discrete random variable x follows Poisson distribution. Find the value when probability of x is at least 1. Now, x is at least 1. At least 1 means what? 1, 2, 3, and so on up to infinite. This is at least 1. Now, how to solve this at least 1? So, we know that at least 1 means 1 minus probability of none. So, 1 minus probability of x equal to 0. 1 minus probability of x equal to 0. So what is mean here? See, here ex is given. Ex means what? Expected value. And expected value is nothing but mean. So expected value is nothing but mean. So mean is 2.20. So 1 minus e to the power of minus 2.2, then 2.2 to the power of 0 divided by factorial 0. So let's put the values. 1 minus 0.1108. So what is the result? 0.89. This is the result for first part. Okay, this is the result for first part. Yes, Prakash, you are correct. Infinity means the last value, that means the bigger value. So because here n tends to infinity, n is not infinity. So always whenever we are talking about infinity, we are talking about tending towards infinity, all right? Great. So the answer is 0.89. This is the first part. Now, second part is a bit different one. What the second part says, see, find out the probability when x is less than equal to 2 divided by x is more than equal to 1. Now, what this part want to say? I will write down here probability where x is less than equal to 2 divided by x is more than equal to 1. So, you might have discussed the formula for PA upon B in the probability chapter. You have already done this. PA by B. PA by B means PA intersection B divided by PB. Probability of A intersection B divided by PB. And this intersection means what? Common. Intersection means common. So what is common between A and B? See, A want to say that x is less than equal to 2. According to A, x is less than equal to 2. Less than equal to 2 means 2, 1, and 0. X cannot be negative. And as per B, x is more than equal to 1. That means x includes 1, 2, 3, and so on up to infinite. So what is common between them? We are talking about A intersection B. That is common between A and B. So what is common? 1 is common. Also, 2 is common. 2 is common. So we can conclude that in numerator, we are talking about probability when x is 1, 2. 1, 2 divided by probability of B. That means what is B? X is greater than equal to 1. And whenever it is greater than equal to 1, we can also write as 1 minus none. So we can solve it as 1 minus probability of none, that is x equal to 0. X equal to 0. So this is the main way to solve the question. This is the main understanding which we have to apply here or develop here. All right. Now we can apply the values. So you can solve them separately and then divide, or you can put the values at one go also. There is no problem. So in numerator, what we have to do? We have to find out probability of x equal to 1, 2. So first of all, we are solving numerator. E to the power of minus 2.2, then 2.2 to the power 1 upon factorial 1 plus 2.2 to the power 2 upon factorial 2. So what is the given value? It is 0.1108, then 2.2 plus 2.2 square, and then divided by 2, it is 2.42. So what is the result? 0.511896. 0.511896. This is the required numerator. This is the required numerator. Now denominator is at least 1. We have already solved at least 1. So let's substitute the value here. 0.511896 divided by 0.89, or if we write the exact value, it is 8892. So finally what we are getting, 0.58. 0.58 is the final answer. Yes. So many of you have given the answers. Kanishka has given, Soumya has given, Azil and Anushka Gupta. Right. So whenever there is A upon B format, we have to take out the common, and after that we have to solve. All right. Now let us take some different questions from back. And this normal distribution part is for tomorrow. We will discussing these questions tomorrow. Yes. Now some additional points for Poisson distribution. Poisson distribution is known as Poisson distribution is basically known as uniparametric distribution. Uniparametric distribution. Why it is uniparametric? Because there is single parameter. And what is that single parameter? That is known as M, mean. So mean is the single parameter for Poisson distribution. So it is known as uniparametric, whereas binomial is known as biparametric distribution because N and P, these were the two parameters in binomial distribution. So in question number 21, we can see that which one is uniparametric. So Poisson distribution is basically uniparametric. Then for Poisson distribution, which of the following is correct? Mean and standard deviation are equal? No. Mean and variance are equal? Yes, it is correct. Standard deviation variance are equal? No. So only option number B is correct here. Then Poisson distribution may be unimodal or bimodal. So we have discussed if mean is a whole number, then there will be two modes, k and k minus 1. Let's say if mean is equal to 4, then mode will be 4 and 4 minus 1, that is 3. But if mean is not a whole number like 4.2, then mode will be equal to simply 4. So Poisson distribution is unimodal as well as bimodal. So we can say it is A or B, unimodal or bimodal. Soumya is asking in exam what we have to choose, approx value or the correct value. See, in exams, whatever is the option, choose accordingly, because both options cannot come together. Like 0.488 is also coming and 0.49 is also coming. Such close option doesn't come into exam. So if 0.488 is there, select that option. If 0.49 is there, then select that option. Okay. Then yes, 25, a binomial distribution with parameters n and p can be approximated by a Poisson distribution with parameter m equal to np. So when will binomial distribution tends to Poisson distribution? So we know that binomial is having finite values and probability is not close to zero. But whenever n becomes very large, such that n tends to infinity, p becomes very low, that is tends to zero, and np is a finite value. np is a finite value. Then binomial will get converted into Poisson distribution. Binomial will get converted into Poisson distribution. Okay. Now, most important, continuous probability distribution. So continuous, we know that normal distribution. So this will be covered in tomorrow's class. Yes. Now we are doing set B, question number 9. Question number 9 from set B. So what this question number 9 says, if the standard deviation of Poisson variate x is 2. So what is given? Standard deviation is given 2. What is probability when x lies from 1.5 to 2.9? Now you can answer this, guys. How to do this question? Question number 9. We have to find out standard deviation. Sorry, standard deviation is 2, and we have to find out the probability where x lies from 1.5 to 2.9. So how we will calculate mean here? What will be mean here? Yes, Raghavan says question number 9 from set B. Yes, Raghavan, we are doing this question only. So standard deviation is 2. What will be mean? So we know that the square of standard deviation is variance. So when standard deviation is 2, variance will be 4. And variance is equal to mean. Variance is equal to mean. So mean is basically 2 square, that is 4. And what is the value of x? X is always a whole number. And in this case, it is lying from 1.5 to 2.9. So between these two values, there is a single whole number, which is 2. There is a single whole number, which is 2. So now m is available, x is also available. So let's substitute the value e to the power of minus 4, 4 to the power of 2 upon factorial 2. Now you can simplify. 4 square is 16, 16 upon 2 is 8. And 8 you can multiply with 0.018. So what you are getting? 0.144. Option number D. We are getting option number D is correct. All right. Great. Most of you have given the correct answer. Now, similarly, we can do next question, that is 10. If mean of a Poisson variable x is 1. Mean of Poisson variable x is 1. What is the probability when x takes the value of at least 1? X is at least 1. So mean is 1, and we are saying x is at least 1. So x equal to 1, 2, 3, and so on. So we will solve as 1 minus p, x equal to 0. So 1 minus e to the power of minus 1, 1 to the power 0 upon factorial 0, upon factorial 0. Now you can solve this. So how much we are getting? 0.632. 0.362. This is the required answer. Now the next one, that is question number 11. 11 is a good question. If now what this language means, if x follows Poisson distribution with parameter m, and its coefficient of variation is 50. So 50 is what? CV, coefficient of variation. Then what is the probability that x would assume non-zero values? X would assume non-zero value. Non-zero means 1, 2, 3, and so on. And also CV is given. So first of all, we have to find out mean. So how we will calculate mean here? So CV is equal to 50. Now what is the formula for CV? CV is standard deviation upon mean multiplied by 100. This is the formula. Now, in case of Poisson, we know that mean is equal to variance. So we can write standard deviation as neta and mean as neta square. That is square of standard deviation. Multiply by 100 is equal to 50. So from this, what we are getting? We have cancelled. Neta also get cancelled. So basically, standard deviation is equal to 2. So if standard deviation is equal to 2, then variance or mean will be 2 square. That is 4. So from coefficient of variation, we have computed mean as 4. Mean as 4. Now we can solve further. What is our requirement? Non-zero value. So non-zero value means 1 minus probability of x equal to 0. So 1 minus e to the power of minus 4. 4 to the power 0 upon factorial 0. Upon factorial 0. So 1 minus 0.018 and the final result will be 0.982. Yes, Adivya has given the answer, Kanishka and Rushita. Got it, guys? So this is question number 11. All right. Now, 12th one. You can try this now, 12th one, and give the answer. If 1.5% of items produced by a manufacturing units are known to be defective, this is the probability of defective. What is the probability that a sample of 200 items would contain no defective item? No defective item. So you have to try this and give the answer. So 1.5 is basically probability. 200 is n. And what is our requirement? No defectives. There should be no defective item. So what to do? First of all, we have to calculate mean. Mean is equal to n multiplied by p. N is 200, p is 1.5%. So 1.5% of 200 is 3. It is 3. And x, no defective item, that means x equal to 0. Now we can solve e to the power of minus 3, 3 to the power 0 upon factorial 0. 0.049, or we can say 0.05. 0.05. Shunaya, Priyanka, Mishra, Kanishka has given the answer. Shania says 12th number question is very easy. That's great. Naren has given, Vinayak, Akansha, Shubhi, Soumya Bhattacharya, Vinayak, and Adivya. All right. So now, similarly, you can try question number 13 also. Px equal to 1 and x equal to is given, and we have to find out mean of x. We have to calculate mean of x. So we can compare both the sides and cancel some of the things. Mean will get computed automatically. So this is very much easy, and we have already done this type of questions now. Let's read question number 14 also. If 1% of an airline's flight suffer from minor equipment failure in an aircraft, so what is the probability that there will be exactly 2 such failure in the next 100 such flights? So what we have to find out, 2 failures in next 100 flights. So what is the mean? Mean here. Mean is equal to n into p. There are 100 flights and probability of defect is 1%. That means mean will be 1. And what is the requirement? That means exactly 2 such failures. So x is equal to 2. Now you can solve it. Great. Many of you have given the answers for 13 also. That's super fast speed. That's great going. Because in examination also you have to be super quick. And in such type of questions, we are doing great things. That's amazing. So m is 1, x is equal to 2. Come on, now you can find the answers. E to the power of minus 1, 1 to the power of 2 divided by factorial 2. So how much we are getting? 0.184. Great. Again, many of you have given the correct answer in one go. That's great going. 0.184 is the perfect answer. Now we are taking the next question, which is question number 15. If for a Poisson variable x, f2 is equal to 3 times of f4, what is given? F2 is equal to 3 times of f4. What is the variance of x? We have to find out variance of x. So let's put the value. So in bracket, it is nothing but x. So x is given and we have to find out the variance. So e to the power of minus m, m to the power of 2 upon factorial 2 equals to 3 into e to the power of minus m, m to the power of 4 upon factorial 4. So what we are getting, we can cancel e to the power of minus m, m square also will get cancelled. So what is left, we can write this as m square is equal to 4 factorial can be written as 4 into 3 into 2 divided by 2 and 3. So we can cancel 3 and 3, 2 and 2. M square is equal to 4. So M will be 2. M is equal to 2. All right. Dechuvi Ponappa is saying, I'm able to do everything except for the calculation. Please help me with it. Sure, Dechu, we will help you with the calculation also. I will talk with you, don't worry. All right. So M is equal to 2. And what is required in the question? Variance. So we know that mean is 2. So variance is also equal to 2. Variance is also equal to 2. All right. Great. So this was question number 15. Now let me take some of the theoretical concepts from this beginning part. Yes. So this is the theoretical part, the Poisson model. Poisson model. So these conditions we have discussed in a simple manner. Now just we are reading from this part so that you can have this understanding also. So let us think a random experiment under the following conditions. So what are the given conditions here? The probability of finding success is very small. That only we have discussed, very small because it is close to 0. Now it is talking about also in a very small time interval. So such kind of examples also we have taken. That means number of customers arriving in a car showroom per minute. Number of customers arriving per minute. So per minute is a very small time for arriving the customers. So we are taking a very small time interval and we are measuring the probability of entering a new customer. So in such cases, Poisson distribution is used. So for this small time interval, what is written? T and T plus dt. Just what we have done in derivative. That is a small change, minute change. From t, we moved up to t plus dt, such that that change is negligible, or we can say that it is tending towards zero. Exactly not zero, but it is towards zero. So time is what? K times of t, and k is a very small value, so which is near to zero, but not exactly zero. Then second, the probability of having more than one success in this time interval is very low. So probability of success is very low. And the third one, the probability of having success in this time interval is independent of t. Probability is always here independent of time as well as the earlier success. Because it doesn't matter with past, customers can arrive anytime. So it is basically independent. So based on this, we have discussed this formula for probability. Then also we have done earlier that sum of all is always equal to 1, because sum of all events in a probability is equal to 1. That is P1, P2, P3, and so on up to 100, 200, whatever is the number, it is equal to 1. The total is always equal to 1. So this is given here, F0, F1 plus F2 and so on. The total is equal to 1. Then Poisson distribution is known as uniparametric distribution because it is having only one parameter. It is having only one parameter, that is m. Now, mean of Poisson distribution is denoted by m, or it can also be denoted by mu. So it is, the formula is simply n into p. And variance in case of Poisson is equal to mean. So mean and variance are equal. So similar to binomial, Poisson can be unimodal or bimodal, which is depending basically on the parameter m. So m, that is mean, is the only parameter on which it depends. Then mode we have already done. If mean is a whole number, there will be two modes, k and k minus 1. And if mean is not a whole number, there will be single mode, that is k. Then Poisson approximation to binomial distribution. So this is the basic condition. If n, that is the number of independent trials of binomial distribution, tends to infinity. If number of trials are increasing such that n tends to infinity. And p, the probability of success is tending to 0. So np remains finite value. NP remains the finite value. So in such case, we say that binomial got converted into Poisson distribution. Poisson distribution. And also there is one additive property here, which says that if X follows Poisson distribution with parameter M1, Y follows Poisson distribution with parameter M2, then X plus Y will also follow Poisson distribution with parameter M1 plus M2. M1 plus M2. All right. So some of the students are getting difficulty in calculation of E. So I am sharing it with you once again. So we know that value of E is simply 2.7183. This is E. If we have to calculate e to the power of minus 1, this means 1 divided by 2.7183. So you can divide this and get the answer. 1 divided by 2.7183. So how much we are getting? 0.36787. Okay. If we have to calculate e to the power of minus 2, This implies 1 upon 2.7183 whole square. Whole square. Similarly, if there is e to the power of minus 3, then 1 divided by 2.7183 whole cube. And e to the power minus 4 means 1 divided by 2.7183 to the power of 4. Now, how to solve this into calculator? Say, if we talk about the power 4. So first of all, what you can do, you can check your calculator screen. There should be nothing into the memory. The screen portion should be empty. M sign should not be there. If there is M sign, just remove it. All right. The screen should be empty. M sign should not be there. Then what you have to do? 1 divided by 2.7183 equal to. So as soon as you press equal to, this is becoming square. One more time you press equal to, it becomes cube. One more time you press equal to, it becomes power 4. So we require power 4. That is why we are pressing equal to 3 times. So it becomes power 4. Now what to do? Now you have to, after pressing third equal to, press m plus. Now 1 divided by MRC equal to. So as soon as you will press MRC equal to, you will get the result 0.018. You will get the result 0.018. Okay. All right. Now let us take 2 more questions from set number C. Monica is asking about question number 2 from set C. Yes, Monica, this set C question number 2 is from binomial distribution. So you have to solve as per binomial. So I will give you the hint. X is a binomial variable such that 2 times of P x equal to 2 and P x equal to 3. Mean of X is known to be 10 upon 3. What would be probability that X would assume at most value 2? At most value 2. So here you have to apply the formula for binomial. So in yesterday's class, we have discussed the formula, that is NC x, then P to the power of x and Q to the power of x. So you have to apply that formula here. And after applying that formula, you will get some of the missing figures, some of the missing values. Okay. So by applying that formula, you can solve it now. Shania says, due to your teaching style, now my maths became favorite subject, and I hope that I will score the maximum number in this subject. That's great, Shania. You will do this. And not only you, everyone, each one of you can do this now. Okay. So let us take some more questions. Question number 11. The question number 11 says, a renowned hospital usually admits 200 patients every day. So what this question says, a hospital admits 200 patients daily. 1% patients on an average require special room facility. Only 1% requires special room. On one particular morning, it was found that only one special room is available. Only one special room is available. Then what is the probability that more than 3 patients would require special room facility? What is the probability that more than 3 patients would require special room facility? So this is what we have to calculate here. So accordingly, we can see what is given in the question. Let us check what is given here. So n is basically 200. N is 200. And probability is 1% because 1% requires the special room facility. So what is mean? Mean is 200 multiplied with 1%. So what is 1% of 200? It is 2. So mean is 2. And what is the requirement? What is the probability that more than 3 patients would require a special room? That means more than 3. X is more than 3. So more than 3 means what? 4, 5, 6, and so on. So for this, we can solve as 1 minus p x equal to 0, 1, 2, and then 3. 1 minus p x equal to 0, 1, 2, and 3. So let's do this. 1 minus e to the power of minus 2 is taken as common. Then m to the power of x. What is m? 2. 2 to the power of 0 upon factorial 0. 2 to the power 1 upon factorial 1. 2 to the power 2 upon factorial 2. And 2 to the power 3 upon factorial 3. So now we can apply the values. We can substitute the values here. So 2.7183 square and then 1 divided by MRC, we are getting 0.1353. Inside bracket, we are getting 1 plus 2 plus 2 and then plus 2 cube is 8. 8 divided by 6 is 1.33. 1.33. So plus 2 plus 2 plus 1. Multiply by 0.1353. So minus 1. So 1 minus 0.8 something is there. And we are getting the final answer as 0.143. 0.143. That is option number A. So in this way, we can solve the question. Azil says today's class is very interesting. Manpreet says thanks for making stats easy. That's great. Srashti says you are great. Your teaching style is so good. Thank you. Thank you very much. Pooja says just because of you, it became more and more easier to solve. That's amazing. All right. So this is the correct answer. So again, some of you are getting challenges in calculation of E. For E, you have to clear the memory from your screen. See, if you are having this memory part M sign on your screen, you have to remove this first, and it can be removed by pressing MRC button 2 times. So you can press this MRC button 2 times. So the memory will get removed. Okay, it is now removed. And after removing this, you can now square or cube or take the power 4 as per the requirement of question and then solve further, right? And such techniques are must for each and every chapter, whether it is like central tendency or like any other chapter, because most of the calculations can be done on this calculator. And you are not supposed to write all those calculations in your rough sheet and all that, because that will take a lot of your time. So you need to practice a lot on this calculator tricks, because if you know the calculator tricks, you will sure do 10 to 20 questions more in examination. Otherwise, on an average, many students reach up to 60 questions, 60 or 65 questions. They are unable to attend more than that question. But if you follow the short tricks, you follow the calculator tricks, you will be able to solve 100% questions in your examination, right? So that is one of the most important things. And always you can take your self-assessment. You can try solving 100 questions into 2 hours and check where what is your speed and where you are lacking. So whatever is your lacuna, you can improve that because still you are having around 90 days available. You are having 3 months available. So you can work on this and remove all your fears and phobias so that you can score more and more marks. So that is very much important. Muskan says this chapter is very interesting. Yes, Muskan, this is really interesting. Binomial, Poisson, as well as normal. And tomorrow's part, normal distribution is more interesting than binomial and Poisson, right?